This is an area model. I have drawn the area model for you. What equation or equations do you think it represents? Pause the video and write down some equations that you think it might match. Okay, let's see how you did. This rectangle has 600 in its area. So I know if I were drawing this in a model, 600 would be in the center. It is 1020 high, and it is 1020-30 long. What equations match this area model? Well, let's look. 20 by 30 is 20 times 30 equals 600. Or I could say 30 by 20 equals 600. What would the division problems be? This symbol gives us a hint. I know 600 is inside, and we are dividing by 20, so the quotient is 30. I can also write this 600 divided by 20 is 30. Or 600 divided by 30 is also 20. Let's get more complicated. I have added to my area model, and it's a new area model now. How would I draw this area model? And what would be the equations to match it? Pause the video and give it a go. Okay, let's see how you did. I'm going to draw my rectangle, and I have some hundreds and some tens. So I'm just simply going to separate the hundreds and tens. Here I have 1020 high, and here I still have 30 long, but I've added 1, 2, 3 more long. Now if I look at my hundreds, it's 20 by 30, and I can see that is 600 because 2 times 3 is 6, so 20 times 30 is 600. In my tens place, it is 3 by 20, 10, 20, and I can see that is 30, 60. If I put it all together, that is 660. Let's check this with some equations. What equations would match it? Well, I have 20 times 33 is 660. 20 times 33 is 660. Or 33 times 20 is 660. What would the division problems be? Well, I have 660 as my area, and I could divide it by 20 to get 33. Or I can have the same 660 and divide it by 33 to get 20. Is there a way you could check if these equations are accurate? Could you use partial product or standard algorithm? Go ahead and check to see if our equations are correct. I have added more to our area model. What is the problem now? How would you draw this area model? And how can you then write some equations to see if it's accurate? Pause the video and give it a go. Okay, let's see how you did. First, I'm going to draw an area model, and I notice that this has the blue hundreds, the green tens here, and the green tens here, and the yellow ones. So I'm going to draw an area model that looks the same as this rectangle. I have my blue hundreds, my green ones, or excuse me, green tens, my green tens here, and my little yellow ones. Now let's look. It is 20 long here, but there is 1 here. It is 21 long now, or excuse me, high, and it is 33 wide, or excuse me, long. So 21 by 33. Let's see. 20 by 30 is 600. That's the same as we had before. And 20 by 3 is 60. 20 by 3 is 60. But we have a new part. Here we have 1 by 30. It's 1 by 30, and that is 30. And here it's 1 by 3, and that is just 3 little ones. Let's go ahead and add this up. 600, well, I'm going to do my tens first because 60 and 30 is easy for me. That's 90. And I also have 600, and I have 3. So that's 3 ones, 9 tens, and 6 hundreds. It is 693. Pause and try another strategy to check if this is right. Do you want to try partial product, or do you want to try partial quotient? Give it a go. Let's connect this to division. We know that there is 693 in the area model, and we divided that by 21. Well, if I think about this, 21 is pretty close to 20. I'm going to use partial quotient. I know into 69, that's 600. I can fit how many 20s into 600? Or I'll think small, how many 2s into 6? I can fit 3, so I'm going to go for 300. 300 times 21 is going to be 630, because 3 times 10 and 3 times 1 and 3 times 2. And if I see what I have left, I have 3 left and 60 left. 63. I think I can fit at least 2 more 21s. So I'm going to put 2 21s. 2 21s is, let's see, 42. Take it away. I have 21 left. Ooh, I can fit 1 more 21, and I'll have nothing left. Let me add this up. 303. Somewhere I have a mistake, because that is not, I don't have 303, I have 33. Where was my mistake in my partial quotient? Can you find it? I found my mistake. I said that there were 321s in 693, but there's not 300 because that's in the tens place. If it was 1, 2, there would be 300. But there are actually only 30 because 30 times 20 is 600. That was my mistake. If I change that, I can see that then it equals 33 and I have nothing remaining. Using partial quotient, 33 is my quotient here and 33 is my quotient there. Let's try it with standard algorithm. 693 divided by 21. 21 can go into 69 3 times, I think. 3 times 21 is 63. I have 9 minus 3 is 6. Nothing left there. Bring down the 3. 21 into 63, I think it will fit exactly 3 times because 1 times 3 is 3 and 2 times 3 is 6. So 2 times. 2 times 1 is, or excuse me, 3 times. 3 times 1 is 3. 3 times 20 is 60. Subtract, I have 0 left.